Just pending. Okay, we are officially here. Okay, welcome everyone to the fifth and last knowledge sharing session for this hackathon. For those of you who have already registered to the Hack9, you will have another session where we will present you the task itself. If there are people who haven't registered yet up until now, do it immediately. Today, Ana Maria and myself will show you what Azure has to offer in regarding big data and what services you can use, how they can help you to manage your big data and get some insights and value from it. So if we look at the agenda, first of all, we will talk about some big data concepts. For those who have already who have participated in yesterday's session, this will be a recapitulation for you. Then we'll go over storage, real-time processing, and batch processing, which are more data engineering concepts. Then Ana Maria will tell you more about machine learning and dashboarding, the fun stuff. And we've also prepared 2 examples at the end to show you how you can do stuff with data, right, on Azure. So first things, big data concepts. What is big data? For some weird reasons, the people who thought about describing big data found words that start with the letter V to explain them and to explain dimensions of this big data. So you've got catchy names for these definitions like 3 Vs, 5 Vs, 7 Vs, 6 Vs. I like the number 5, so that's the one I took here. The first dimension of this, first dimension of big data is volume, right? It's size. Now, if you ask me, what is big data? What is big? Like, is it gigabytes, terabytes, petabytes, zettabytes? I'd say yes, all of that. Every data source that has an increasing size will eventually become big data. So the volume is not the most important, but is growing the minute to minute. Now, velocity is the speed of data generation, right? So the data can come really quickly and we have to be able to ingest all of that data, and it can change really quickly. So we have to be able to adapt to those changes. And that data can be all of a kind. That is the third dimension, variety. We would like that it's completely structured and, normalized and like relational tables, but it's not. It can be semi-structured, unstructured. It can be anything you can think of. Every byte is some form of data, so to say. Now for veracity, the fourth dimension, it's quality, integrity, credibility, and accuracy. In some form, you have to trust your data sources, but it's not only enough to trust them. You have to validate the data. You have to be sure that it's valid and it won't create some errors and false insights from that data in your further processing. And the fifth dimension is probably the most important one. It's called value. Now, you've all heard that the data is new gold. It's not. Data is locality where you could find gold. Now, you have to dig gold mines in order to have a process to process that data. And then after that, you will have to refine it. And when you refine that gold, you will have those nice things that have value, like gold plates or whatever. So let's see how such a gold mine would look like in this system of big data. What you see in front of yourself is a conceptual diagram of a system that works with big data. Going from the left to right, the first thing we have is data sources, and as I said, they can be everything. We can pull data from them. It can be somewhere on the cloud. It can be on local machines, some older databases. So we pull from them, and they can also send data to us. We can allow them to send, and we ask them to send it like that. Now, when we pull data, we have to store it somewhere. This is the first step, data storage. This storage needs to be scalable. It needs to encompass that big data, that volume of data. Now, such big data have to be processed, and in a sense, it can be processed with batch processing. I'm going on the upper layer, and this batch processing is mostly takes time because of its complexity and the sheer volume of data. So you're going to clean your data, you're going to join your data, you're going to analyze it, and when you can hash it, and when you kind of from big data gets a little bit smaller data or refined data, you store it in some form of analytical data store that is optimized for extracting information from that refined data. And at the end, you have analytics and reporting when you can show those insights to people of interest. Now going to the lower part, when I said they can push data to us, we have to be able to ingest that data at real time, and we have to process it at real time, because sometimes it's important to have some insight and some actions immediately. It's too late to have these insights and actions tomorrow. Something already happened and we missed the chance. So there is stream processing that also does some work on real time, populates the analytical data stores and send those insights to analytics and reporting. In the middle, you see machine learning. In some systems, that is the core of the system and value. In some, it's form of enrichment, where we can, on the data that we are gathering, find some insight with machine learning. On the lower part, it's orchestration. This is the, I'd say, main block that helps everything from it to work properly, and if it fails, to try again or fix it itself. So this is like a conceptual diagram. Not every big data system will have all of these blocks, but most of them do. And this would be an example on Azure. We won't go too deep here, but what is presented here, it's something what is called Lambda architecture in big data systems. On the top, you can see this stream processing, ingesting and processing that will do immediately when the data arrives. And the lower part, we have ingesting from the data sources and batch processing. We will touch, I think, most of the services here, so I wouldn't tell them by what they are right now. So first things first, storage, right? Without storage, we can't do anything. Now, on the first slide, we have SQL, NoSQL, and cache. And you may ask, how did I combine these concepts into one slide? And I'd say this is not your primary storage in big data. We all like the relational database services for our transactional processing. They are fantastic, but all of those nice things became a bottleneck when big data came into place. These services and this stuff can help you in points of enriching your data from something that is stored in relational database, NoSQL, or cache in your batch processing and your stream processing. For example, you have some static data that does not change too much, and you have to quickly gather it. You can store in these services, or it can be at the end, supporting applications of analytics. And on Azure relational database services, you can have a managed service that's called Azure SQL Database. It has dedicated and serverless options. Also database for MySQL, Postgres, SQL, MariaDB. For NoSQL, the de facto option is Cosmos DB. You've got key value pairs, documents, graphs, and columnar options. And for cache, there's Azure Cache for Redis. Now, why did I also include cache here? Cache is in-memory data store. It's not used only for quickly getting some in web services, some data. You can store it here in your in Azure Cache, the things that you will need and require in your processes of big data wrangling. Now, talking about Azure Storage Account, this is a service that combines multiple things. First and most important one is blob storage. And this is your classical object store, same as S3. It has flat structure, and you can store anything, basically any type of any size. The interesting thing is Data Lake Storage Gen 2 that has hierarchical blob storage. This is what I would call blob storage on steroids, but I will have a complete slide on it, so we'll check it on the later one. I've mentioned here table storage because that is simple document storage. If you know that you need document storage and you don't want all the fancy and nice features of Cosmos DB, you could use table storage for a simple working with it. Also for queue storage, if you want some messaging, no, not data ingestion messaging, but communication between services or queuing something, you can use queue storage. but it does not guarantee you first in, first out. For example, for more features, there are other services like Service Bus. Now let's go over to the Azure Data Lake Storage. I boldly said at the top that this is the only storage service you need. Now, that's not completely correct, but let's see why. Data Lake Storage has hierarchical namespace. What does that mean? Comparing to blob storage and S3, this service or this part of this service actually has a file system organization. You do have folders and files in folders. So that helps you to easier management. For example, if you want to rename a folder, you just rename the metadata. You don't have to rename every object that could be in that folder. That is done in object storage. And it also has a better security when you have how they call POSIX security on each file or each folder combined with other security features. Now behind it, it's what's called ABFS driver, which is actually Hadoop driver. Same as with S3, I don't think they say that it's really Hadoop, but if they have the driver that is completely compatible, it surely is, with maybe some additional features they've built themselves. What this offers is better connectivity to any service that is already connected with Hadoop, and also it allows performance. Now, how does it allow better performance? Something that is basically indexing on data lake is partitioning. You create your organization of data lake with folders and files in them. And basically, if you want, if you have a organization like on this slide, you could easily just find the data that's in this day of the month of the year of that entity. The Hadoop will let you do that quickly because of the driver above. Now, I wanted to mention the file formats here because they are the main things when building the data lake that you should think about. You have two families that are row-based and column-based. The row-based data file formats are CSV, JSON, and Avro, and they are good for ingesting data record by record or finding data record by record. When you want to do some analytics on big data, the column-based file formats are priority, and there you have two options, Parquet and ORC, where Parquet is more used, so to say. Now, this cannot only be the only storage you need, but is the primary one you should think about while doing the big data. Now, going forward, we have something called analytical data store. If you recall, that is almost at the end of the pipelines, like batch processes and streaming processes get data into these analytical stores. And data warehouse that you can build in Azure Synapse Analytics service is a data warehouse that is centralized repository where you store historical and current data. What it does, it enables reporting, and it enables people who are good with business intelligence and know what they are doing and know what they want to find in data. They can do reporting analysis and etc. Now, now a new kid in the block, well, not new, but that's something that's popular today, is data lakehouse. Instead of having a warehouse, which is some form of proprietary system that you have to pay or build yourself, you can build your warehouse upon the data lake and have the storage on the data lake and use some form of serverless processing upon it to build some organization like data warehouse. Now, for the second analytical storage, the store I mentioned here is Azure Data Explorer, and it's mostly important for real-time analysis. So time stream analysis allows you that good throughput that you can ingest the data immediately, and it uses something called the custom query language that's similar to SQL, but it can immediately show you visualizations and analysis. So it can be a good thing to try out. With this, we finished the main storages. Now we are going to the real-time processing. this is a topic for itself. Unfortunately, on Hackathon, you won't really have huge amounts of data coming in for this to be really relevant, but I wanted to talk about it. When you have real-time processing, the most important thing is to have stable message ingestion. You need to be able to ingest many thousands or even millions of records per second. And for that, there is definitely a service, well, not service, technology or open source, that is Kafka. And on Azure, that is Event Hubs. Again, I don't think it's completely Kafka in the background, but they have some of their proprietary features built in the Event Hubs that even make it better. And it is completely managed, so you don't have to think about Kafka cluster. You just say how many records you expect, and they give it to you, and you pay for it, obviously. So yes, it's distributed event streaming. I won't go into what makes it distributed is partitions and consumer groups. I won't go too much into the detail here, but you can check it out later on. Now, the other option with this is IoT Hubs. This is a service meant for IoT devices. In the background, yes, there is an event hub that is, well, ingesting that data. But additional features in IoT Hubs are some of them you can see here, and that's per device identity. When you create a device in IoT Hub, it will know where is it coming from and who is sending the data. So you can use immediately do telemetry on those devices. You can not only send device to cloud messages, but also send cloud to device messages, meaning that if there's some action needed to be done on the device level, we can tell them to do that. And the most interesting thing here is IoT Edge. It actually allows you to do some processing on the device itself. Sometimes it is late to have some action, have an event or message come to the cloud, then cloud to process it and send the response back. With IoT Edge, you can basically do things on the device and manage the things that do those on the device itself. Now, how do you do the process of such high streaming data? There are a couple of services, and the first one is completely managed stream processing service called Azure Stream Analytics. What you have basically here is that you define your inputs. That can be event hubs, IoT hubs, but there also can be some, they can be also tables in SQL. Then you can use T-SQL query, and this can be a really complex one. You can have multiple stages of this query and also have multiple outputs. Basically, you expect how much data you're going to receive, and you pay for it, so it is not serverless, unfortunately. Also, you can use Spark streaming, which is not completely real-time, but is micro-batching, near real-time. And you can use it in Azure Synapse Analytics. We will see this service more and more, and later on you'll see why, but there's something called Spark Pool there. Obviously, if you don't have too many records coming in, you can use Azure Functions or durable functions if you require some state. And it is do it yourself. You write your own code, your own connections, and you can use it for a low number of events because it's completely serverless. So you pay only for what you use, which is good. And the first two services are not like that. They are dedicated. You pay how much it runs. So that was a bit of overview of real-time processing. Now we're going to do something which you will definitely use, that is batch processing. And what batch processing means is that you have to transform your data in some way from the start to the end. And here we can see, again, Azure Synapse Analytics. It's a one service to rule them all, definitely. We all know how that went for Sauron, but we'll see how that will go for Microsoft. So far it's going well. They have a lot of other services included in Azure Synapse Analytics. And basically you have a one portal where you can use them all, which is always good. The first things here are dedicated pools. And this is the one I've mentioned earlier, data warehouse, that you build and maintain. And I'll be honest, I wouldn't go for this on the hackathon because it will take a long time and it is expensive, unfortunately. It is dedicated and not serverless. The next thing is serverless pools, and they are obviously serverless, but what does it mean? This is serverless processing tool. You write SQL queries in it which you can use. You can do ETLs and ELTs. The difference is in ETL is that you extract your data, transform it, and load it somewhere. In ELT, you extract, load, and transform. I'd say the other is better, but don't take it for granted. Why? Because if at the end something is wrong, and you check that the data from the source you've loaded is good, you made a mistake in this transform part, so you have to check it. Okay, so with SQL, you can definitely write some transformations. Now, what does it mean, data lake creation? It enables you to create something called external tables upon the data lake we mentioned earlier. Now, these external tables are not the real tables. They are just some metadata that, with conjunction with that Hadoop driver, allows for better analytics, like predicate pushdowns, or etc. So you can use serverless pools to do these things, and when you are happy with them and you can automate them, you create a store procedure with the help of some orchestration tool you can run at any point of time. The other pools we have is Apache Spark pools. Now, if you haven't heard about Spark, it's de facto standard for processing of big data. It's not completely serverless, it is, but because of the pause feature, if it detects that there's no activity on that pool for, let's say, 10 minutes, you can configure that. It will pause itself and it won't waste your money. And that, in some sense, it is serverless. What you can do on Apache Spark pools is experiment with notebooks. Notebooks are basically IDEs in browsers. They are fantastic for experimenting, and Spark supports multiple languages. Therefore, you can use those things. Again, ETL, ELT, data lake creations. At the end, you have a notebook that works. You run it with orchestration tool, or you create a job, Spark job, that you can also run on these Apache Spark pools. With Azure Synapse Analytics, we also have data explorer pools, something we've mentioned earlier. They are more for streaming data, yes, but they can also be used for some batch processing from table to table in data explorer pools. So in some sense, they can be used for extract, transform, and load. Now, the next service is Azure Data Factory. I did not write anything here because this picture really says everything about this service. Why? Because it is a kind of orchestration tool, but it also has some transformation options here, and they are no code, low code. I will first go over the orchestration options and features this Azure Data Factory provides. And the first one is ingest. First thing in your processes is to ingest data from somewhere, and this services allows us to ingest the data from a lot of other services. It has, as we see here, 100+ native connectors. They are not only on Azure. You can connect to AWS, you can connect to GCP, and also you can connect to hybrid cloud on premises or whatever. And you just say where they are, where your data is, you provide the authorization and do some checkups, and it will ingest your data easily. Now, the next part is control flow. This is what we think of orchestration. In your pipelines, you can have, or you will have, multiple steps probably. So you can generate those pipelines by point and click and drag and drop. It's no code and low code. You connect those boxes if this fails, do this. If this succeeds, do that. You can have loops, branches, conditional executions, and also you have variables and the parameters with which you can generify your pipelines. Not every pipeline can always be the same, right? So you have to generify them. I will skip the one in the middle, that's called data flow, that's the ETL, and I will go over to schedule. So you can schedule your pipelines to run on wall clock, event-based, something happens, you want to run your pipeline, you can have tumbling window, that means every, let's say, every hour run this pipeline, and they can be all chained. So that's the schedule, and at the end you have monitor to see, did your pipelines actually succeed, and if they did not, what made them fail. Coming back to the one in the middle, data flow, this is especially good for trying out some things. This is code-free, as they say, code-free data transformation. It runs in the background on Spark, some Spark pools that Azure Data Factory will scale out by itself. So you can generate some form of data transformation in Data Factory itself without configuring any Spark pools, any other services that allow you to work with data. You can use Azure Data Flow. And on the example, we'll see one of those. And I failed to mention here, but obviously for batch processing, you can use Azure Functions, but bear in mind that on the first step, the Azure Functions run for 10 minutes. So if you got anything complex, I would go for Azure Functions for that. So this concludes batch processing, and I will give stage to Anna Maria to tell you more about interesting things called machine learning.
We'll see. Thank you, Mihajlo. So hi, I'm Anna. I will discuss a little bit about what Azure has to offer in terms of machine learning. So Mihajlo, can we go to the next slide? Thank you. So Azure Machine Learning is basically a cloud service that allows you to create your machine learning environment. For example, you can accelerate and manage the entire project lifecycle. You can train and deploy your own models. There is a marketplace where you can find different machine learning models, and you can manage, for example, you can do real-time scoring with a managed endpoint. You can do batch scoring with managed endpoints. Azure also offers MLOps, which is for production projects. Like the entire life cycle of a project, you can track and monitor, analyze your training runs. You can do model management, deployment, lineage, and monitoring. And you can also design the DevOps part of a data ingestion pipeline with MLOps. On to the next slide. Azure Machine Learning Studio offers you the possibility to actually see the runs, the metrics, the logs, how your algorithms trainings are behaving. You have those notebooks that also Mihajlo mentioned, where you can author and edit from multiple people at the same time. You can have different data inputs. You can run your metrics. You can create, after gathering some results, you can create some reports. You can also see the pipelines through developer interfaces, and you can even go for AutoML jobs, which is a really cool feature of Azure, because onto the next slide, we will see that AutoML is a cool tool that is designed for two categories of people can use AutoML, those who are DevOps. So there's a Python Azure Machine Learning SDK, and there's also for those that do not have necessarily code experience. And it's like an interface, a notebook that allows you to choose a machine learning model, to train it on your data, gather some insights, check some metrics, and pretty cool things like that. So this Azure Machine Learning Studio can be used both for the SDK for developers and for those who have limited experience but would like to play with the tool itself. So you have automated machine learning. Mainly, it does. It's choosing the best algorithm for your problem from a list of algorithms designed, and also it does automatically hyperparameter tuning. You can also do DevOps for machine learning, the entire integration of the project pipelines, model management, and it's also agnostic related to Python SDK. On to the next slide. The Azure Machine Learning SDK, it's mainly a workspace where you design your pipeline, you add your resources. For example, you could set up a data store to access the data which is needed in the pipeline steps. You design the machine learning compute. You can configure how the training should take place, the training of your machine learning algorithm, and you can construct those pipeline steps and submit the pipeline. So the machine learning studio offers all these possibilities. I suggest for the Hack9 that you guys go and try it because it's a pretty cool tool, and it offers many possibilities. And for my remote mouse, so in terms of dashboarding, it's worth mentioning Power BI, which is offers enterprise analytics solution. You can visualize your data, dashboard your data. You can share insights across your entire organization. You can grab those insights and put them, embed them in your application or a website. You can do data-driven, you can develop data-driven culture. You can access the data from multiple places. It doesn't have to be the same data source. It doesn't have to be the same shape of in the same format and things like that. It's designed to support multiple types of input. You can draw coherent visual and interactive insights. For Hack9, you could try to play with Power BI desktop. There's also mobile version, and you can connect to multiple data sets from Azure storage services. And on to the next slide. It's another encouragement that to use Power BI if you have the chance, because it offers amazing data exploration experiences. So you have this connectivity to your data. You can prepare and model your data with ease. You can get insights and actually put them in a place you work most often. You can also improve data performance and control. And I think it's enough with the theory. We will go to some examples. I will pass the head to Mihajlo again.
Thank you, Ana Maria. I'm sorry, this remote mouse had some latency switching to slides. We'll show you two examples. One is more data engineering oriented, and the other is data science oriented. Let's set the stage for the first one, right? So the example in this and scenario of this example is that we've got some crimes reported in Chicago, that they are coming in and they are stored in some police data storage. Let's say it's a data lake, probably not, but let's say. Data about this, we have date when this crime happened, description of it, and location, right? We have some data about police districts and wards that are hopefully static, and we store them in our Cosmos DB service. What this data is, we have a label and number of districts and wards, and we have its geometry. That's basically saying where this district is on the map, or well, the location of it. We also have locations of police stations that we have information about district, location, and a phone number, so we can call them if something is needed. For this purpose, for purpose of this example, we would do some analytics, right? So we won't do some informing immediately. It's not real time processing. We want to do some analytics on data that's gathered in the last, let's say, X hours, let's say 3 hours, for example. So you see on the right how a pipeline would look like in Azure Data Factory. We have these activities that are interconnected. Here, everything is going to succeed. So everything is the green one, green arrow. And what activities we want to do is we want to copy data from police storage into our data lake in our row zone. Row is sometimes called bronze. It's something you store your data that's as is. You don't change it. That's ELT, extract, load, transform. Then we want to clean and filter our data. We will then enrich our data with this static location information about districts. Then we want to aggregate based on those districts for some kind of reporting and analysis. And at the end, just notify someone that it's finished, right? Obviously, the first thing you have to ask here is how you would know which hour is we want that data, and that's how you use parameters. From the trigger, that is a tumbling window, we can know at which time it started and therefore know the time. That's only one example of parameter usage. So going on to the first activity, which is copy activity. We basically define source and sink. In our case, they allowed us to connect to their data lake, and with that set for that source. And for the sink, we took our data lake to just put everything there. For data type, we've chosen binary here. And what does that mean? We do not care what is there. We want everything as is, as bytes, just bytes. So we'll think about it, what it is later on. You have options. If you know that it's Parquet, it will also let you to do some schema inference immediately. But for this case, we use binary. This activity will connect to their data lake, get the data, and load it to ours. Okay. Next activity is data flow activity, and this is the transform activity in Azure Data Factory. This is the one we talked earlier about, earlier that it's no code or low code transformations. And basically what you do, you can see it on the image down there, you point and click and configure. So for example, a source to our activity here is the ingested crimes reported data in our data lake, and we want to transform it. We want to really be sure that we are taking only the data from last 3 hours. So we're going to filter that data with that second step. And then we have to validate the existence of location, let's say, property. If we have a location, we should branch that into a sink that's called ready for enrichment. That's the data that is ready for the next step on the right side. And if we are missing data, well, we can't do any analytics because we can't find which district they belong to. So when data flow activity finishes, we've got our ready for enrichment data set again stored, something probably in the silver stage of our data lake. Then what we want to do is actually enrich. We've got the information of longitude and latitude, and based on that, we want to find to which district, ward, and community area this belongs, or where it happened, this crime. Okay. For this, I decided to show this notebook that runs on Spark Pool in Azure Synapse Analytics. So you basically have a notebook that you created, tested, it works. you saved it as it is, and via Azure Data Factory, you can run it. Again, the jobs are probably more optimal, but for the purpose of this, we took notebooks. And what you would do here is basically an algorithm that is point in polygon. You've got your point of location, and you've got polygon, and you have to find in which polygon this point belongs to. When we have that data, we mapped our location to district, ward, and community area label. After that, we can create something, we can create a SQL stored procedure activity, which will run our SQL stored procedure on serverless pool. So we've, again, via serverless pool, via console, we've created something, tried it, it works. We can pack it as a stored procedure and allow some orchestration tool like Azure Data Factory to run it and work with it. Here, we should maybe aggregate data on district, ward, community area, and then store it again, maybe in our gold phase of data lake, or maybe input it into Cosmos DB or relational databases or whatever. And at the end, we can, when everything is hopefully finished successfully, we can run an Azure function that will notify someone that is finished, or maybe do some additional insights and analytics, because from the big data, we got fairly small data, so to say. And if you're thinking, well, this is not optimal way to do what I've just described, you would be absolutely right. All of this could have been done with a simple Spark job, but hey, what's the purpose of this example is to combine multiple things. So this is a pipeline in Azure Data Factory that you can use to call other services to do some things for you. And with this, I would finish my data engineering example. Let's go over to the fun things again.
Let's go to the mouse, distant mouse again. Yeah, so this is an example of an architecture that you could have for Hack9. It's a basic example where, for example, I use Blob. I upload a file on that blob. I call an Azure function, so that is configured to be event-driven by my upload, where I do either some small transformation, as Mihajlo said, that it has some time constraints, or call a cool Azure service. For example, you could go for cognitive services, for anomaly detection, for time series, machine learning, AutoML, things like that. Then grab the result from that service and store it on another Azure Blob for output. So in this kind of use case, you would actually take advantage of the serverless functionalities in Azure. I also gave a link to some examples, and yeah, just one, for example, you could use Azure Stream and Analytics, anomaly detection, to get information if there's some spikes in your data, or there are some patterns or even trends regarding the input data that you have, and based on the way you model it. And there's another example, which is onto the next slide. It's more related to how to train your machine learning model. For example, your Azure Data Factory pulls the data from a source database and it copies it. Then it stores it to a machine learning data store as a tabular data set. Then you have to prepare your data. For example, you have a training pipeline that pulls that data from the data store and transforms it further if needed. It groups the data as it's necessary for training the machine learning models. Then you have the ML training model, the pipeline, where you train your machine learning model, and after the model is trained, the pipeline registers that trained model to your own machine learning workspace. within Azure, you can register it in the workspace. Then you can grab the results. It's not mandatory. This is an example of Azure products that you could use. But if you would like, you could store all your predictions in batches in Synapse SQL, and then grab the metrics of some results and do some dashboarding in Power BI to you retrieve the metrics, and you can prepare a presentation with like how is your machine learning model behaving and what are the conclusions that you draw based on the input data that you have. So that's pretty much, I think. Yeah.
This concludes our presentations, and we are ready for questions to answer. No questions, everything is clear.
I have one.
Go on.
I'm not quite familiar with Azure or costs using those services, more with AWS. So the question is, how much was the cost for the proof of concept that we did on Azure of getting things from IoT and storing?
It was more expensive than on AWS.
Okay.
And why is that? Because we did have that IoT hub, which is not serverless. So in the background, it is running. We did took on the smallest one. So I think it's per month, $8, right? So it was running in the background and it was already ready to receive the messages. So yes, the Azure does lack a bit for those serverless services, but it's good for enterprise-ready solutions.
Yeah, okay. But even those 8, it's not quite a lot.
Well, comparing how much on AWS was like $1 or something?
Yeah, something like that. Yeah.
We'll multiply that by 100 and it would be nice.
Yeah. Okay, thanks.
I have also a question. So if you're mentioning ETL, ELT process, so which one is more expensive or cheaper?
ELT is more expensive. You got more data. So you basically copy everything you've got to somewhere and then transform it. So you don't transform it on the fly, right?
Yeah, so basically it's transform, or you do that in store procedures or in SQL. That's is for the persons who are possibly DBA specialists, something like that. So for them, is that convenient?
Yeah.
Is that
I'm mainly going for. Well, I was thinking maybe better to see if you fail in transform, it's easier to test it, right? You have more experience, Costa. I confirm it.
Yeah, I know, but when you say that price to the client, then woohoo! Just for confirm it, thank you, but not thank you.
That is true.
Yeah, that's it for me.
You also don't put pressure on the source systems when the transform part fails. At least you don't copy the data again.
Yeah, that's another good option. Yeah.
Also, okay. I noticed in your Mihajlo, in your ETL, in your example, I saw a store procedure. I think 2 months ago, maybe they introduced the script task for people who work with the SSIS. It was, a big deal. Let's say we were used to SQL tasks in there, and now suddenly we couldn't write just on the fly an SQL statement in ADF. Now we can. So we don't need to write a store procedure anymore.
Thank you. That's a new thing. I have to research it then.
Yeah, it's cool.
Thank you. Any more questions? If there is not, you can reach to us later on. And I'd like to thank you all for attending this presentation, and good luck on Hackathon.
Thank you. Have a good evening. Bye, guys.
Bye.
Bye-bye.
Thanks for joining us. Bye.